Hello, folks. I'm Victor Ribeiro, PhD student in crop science at Oregon State University under Drs. Judy Barroso and Carol Mallory-Smith. Today, I'm going to share some of my research findings on herbicide resistance in Downy Brome. The objective of this study was to confirm if Downy Brome populations were resistant to commonly used herbicides in wheat cropping systems in eastern Oregon. We also conducted a survey to understand Downy Brome management in this region. But during this presentation, we will just cover the resistance screening results. In summer of 2021 and 2022, Downy Brome populations were collected from several wheat fields in eastern Oregon. As we can see in this map, 49 populations were collected from 5 counties in this region. In 2021, most of Downy Brome populations were collected from Morrow and Umatilla County, which is in blue. In 2022, we expanded this collection to Gillian, Sherman, and Wasco counties, which is represented in red in this map. After Downy Brome collection, we brought the seeds to Corvallis, and the resistance screening was conducted in the greenhouse at Oregon State University. Downy Brome plants were sprayed when they were at the 2 to 3 leaf stage using a research sprayer calibrated to deliver 15 gallons per acre. Downy Brome survival was assessed at 21 days after treatment. The percent survival was determined based on the number of surviving plants compared to the total number of treated plants. Downy Brome populations with greater than 20% survival were considered resistant. Here in this table, we have the herbicides used in this resistance screening. We tested the labor rate and 2 times the labor rate for each herbicide. We also included the untreated control just for comparison. On the top of this table, we have Select Max and Assure 2. Both are from Group 1. It's important to point out that these 2 herbicides, they are not labeled for wheat, but they are commonly used in rotational crops in this region, for instance in lentils and canola. In this red box, we have 5 Group 2 herbicides that are commonly used for grass control in wheat. Below, we have glyphosate, which is commonly applied in fallow. So looking at the results, we have the overall resistance for both years here and for all populations. In the y-axis, we have the herbicides tested, and the x-axis, we have the herbicide resistance percentage. In the first box, we have the results for the labor rate, in the second box, the results for 2 times the labor rate. So looking at the first box, we can see that all populations were susceptible to Group 1 herbicides and glyphosate. However, these populations were resistant to all Group 2 herbicides tested. Resistance to Outrider, Osprey, and Powerflex were the most pronounced with 86%, followed by Olympus and Beyond, as we can see here. Similar results were observed in the 2 times of the labor rate, but with a slightly reduction in the resistance percentage. Now looking at the cross-resistance patterns to Group 2 herbicides for populations collected in 2021. For those that are not familiar with cross-resistance means resistance to more than one herbicide within Group 2, for instance, resistance to Beyond and Outrider. So in this table, we have in yellow populations that were susceptible, and blue populations that were resistant for each herbicide tested. In the first column of this table, we have the populations, and on the top row, we have the 5 Group 2 herbicides tested. Looking across the table, we can see different patterns of resistance. For instance, if we look at the first population, G1, we can see that this population was cross-resistant to Outrider, Osprey, and Powerflex. Overall, 18 populations of 21 were cross-resistant to Group 2 herbicides. Looking at the results of 2022, we have a similar table. We are just missing here Osprey, which means that this herbicide hasn't been tested yet. That's why it's not included here. And also we have NT in this table, which means not tested. We can see that resistance to Outrider was prevalent in these populations collected in 2022. And also we can see different cross-resistance patterns across the table. Overall, we observed that 24 populations of 28 were cross-resistant to group 2 herbicides. Here we have a photo to illustrate the herbicide resistance screen. We selected population MOR15 in the susceptible population. So the photos were set up in the same way. So in the front, we have the susceptible populations in all photos. And in the back, we have the population MOR15. The first row means that the control. In the middle, we have the labor rate, and on the right side, the 2 times the labor rate. We can see in this photo that this population was susceptible to group 1 and glyphosate, but it was resistant to all group 2 herbicides here, beyond Olympus and Powerflex. To summarize our findings, we observed that all populations were susceptible to group 1 herbicides and glyphosate. 46 populations were resistant to at least one group 2 herbicide. 42 of 49 populations were resistant to 2 or more group 2 herbicides with different cross-resistance patterns. As conclusions, the widespread occurrence of group 2 resistant Downy Brome populations is of concern, as it limits effective post-herbicide options in wheat. The adoption of quizalofop using aggressor herbicide associated with coaxium wheat varieties offers an effective control option for group 2 resistant Downy Brome populations. However, stewardship must be considered to maintain this technology. Glyphosate still provides effective Downy Brome control in fallow, but alternative modes of action or tank mixes should be considered to preserve its use. Thank you for watching this video. If you have any questions, please reach out to me. And I also want to thank Oregon State University and Oregon Wheat Commission for funding this research.